We are very privileged tonight to have a very special guest with us because Dave Coppage has known Dr. Richter for a long time. I thought I would ask him to come and introduce Henry Richter to you. They're actually co-authoring a book together right now, and it was Dave who put me in touch with Dr. Richter. So Dave, and you already know Dave. I think anyone who's been here any time at all has heard Dave speak more than once. Dave?
Well, thanks, Jim. It's my honor and privilege to introduce a very great American tonight to speak to us, an American VIP of the space program who is the last surviving manager of Explorer 1, America's answer to Sputnik, back on January 31st, 1958. And so Dr. Richter has seen it all the way from the first satellite to this year's exploration of the planet Pluto. And he was instrumental not only with the instruments that went on the Explorer 1 spacecraft that made America proud again after a spectacular flop after our first attempt, by the Navy, but then when Wernher von Braun's Redstone or Jupiter C rocket took off with Explorer 1 on top of it, built by JPL and the instrument containing the instruments that Dr. Richter organized and arranged and put into it, including the instrument that discovered the Van Allen radiation belts. He's been a major part of the beginning of America's space program. He continued to work on the instruments for the Ranger and Surveyor programs and is the architect of the Deep Space Network that continues to monitor spacecraft around the world. So let's give a hearty welcome to Dr. Henry Richter.
Thank you, Dave. Well, let me start out with a little early history of myself to tell you how I got pointed toward creation. I was born nearby in Long Beach. My parents were artists and taught in the local Poly High School. They had been art professors before that at Western State College in Gunnison, Colorado, and then Drake University, and moved to Southern California to get better climate. They thought Gunnison was bad until they moved to Des Moines, and the winters really got them there. I went through schools in Long Beach, moved to Rolling Hills in the Palos Verdes Hills, and then into the U.S. Navy for a short time at the end of World War II. Went to school at Caltech in Pasadena and graduated with a PhD in chemistry, physics, and electrical engineering. From there, I went to a sleepy little research lab in the Arroyo Seco Canyon above Pasadena, called the Jet Propulsion Laboratory, which then was a guided missile research lab, belonged to the U.S. Army, operated by Caltech, and organizationally attached to Redstone Arsenal in Huntsville, Alabama, which was headed by Dr. Wernher von Braun. About the time I arrived at JPL, the world was starting a major program of exploration of spacecraft Earth called the International Geophysical Year, the IGY as it was called, and it was to be an 18-month-long period during a time of high sunspot activity, which is why they chose that particular time, to explore spacecraft Earth from the core, the mantle, the surface, the subsurface, the atmosphere, and near space. As part of the IGY, 2 countries announced that they would attempt to launch rockets that didn't come back, namely Earth satellites. The United States and Russia both put together programs to explore the near space. The U.S. government did what it typically does. This was in 1955. When it starts something new, it held a competition amongst the armed forces, and we were allowed to put proposals in to become the official satellite agency. We, part of the Army, put in a proposal, and the Navy put in a proposal to launch a satellite, and to our dismay, the committee chose the Navy to do the official program, and they put together a project called Vanguard. And so that was the start of the space race between the United States and Russia. The Vanguard folks, we think one reason the Navy got it was Eisenhower was president at that point, and he didn't want to appear to be favoring the Army at all. And so they chose the Navy, which was going to not use military rockets that we were going to use to launch a satellite, but all new, nice, clean civilian rockets. And so they started on their program, and we cheated. We started on ours too, although we had no permission to do so. And so we started developing a launch rocket that would place a satellite in orbit based on a large Redstone rocket that von Braun's group made in Huntsville, and then three more high-speed stages made with small solid propellant rockets that we had developed at JPL. And then we developed a satellite to go on the front of it, and a communication system to communicate to get data from the satellite called microlog. Both programs went on. As I said, ours was done in secret. And on October 4th of 1957, the United States was sort of jolted awake. I remember the headlines in the Los Angeles Times, they were that high. It said, Russia launches Earth satellite called Sputnik. And it was clear our national prestige had suffered. And we sat back to lick our wounds. A month later, the Russians launched a second satellite. The first one, Sputnik 1, was 184 pounds. Sputnik 2, on November 4th, was about 1,200 pounds. It contained a small dog whose physiological state they telemetered. And then the United States needed to do something, and so the Vanguard Navy boys were pushed into an early launch of a test rocket that ended up in total disaster. On national live color TV, the rocket rose about 4 feet off the pad, exploded, and rolled down into a huge ball of flame. The headlines now, instead of saying Sputnik, said Flopnik. They really ridiculed the Navy for the effort. And so something needed to be done. We had had a proposal in to launch a satellite, and we were actually ready to go. We had done 3 test launches already that did not orbit. They were part of the Jupiter Intermediate Range Ballistic Missile Program, and their goal was to test a reentry nose cone, sending it 3,400 miles down the Atlantic missile range and letting it reenter. So we had already tested our rocket. We had a lot of confidence. And so after the Vanguard explosion, the Secretary of Defense finally authorized the Secretary of the Army to let Redstone and JPL go ahead and gave us 84 days in which to launch a satellite. And if we hadn't cheated and had one all built, we would have been in real trouble. But we were ready to go. We just had to find some science to put in it, since it was part of the IGY. And Walt Downhauer and I made a quick trip around the country. I knew most of the Vanguard scientists. So we chose a little Geiger counter made by Professor James A. Van Allen, the State University of Iowa, to measure cosmic rays. And so that's what we put into our first satellite. Anyhow, we launched it, as Dave said, on January 31st of '58. It was a success. and the American prestige was sort of recovered. And JPL went on to do other things at that point. I had a fair career there as chief of the Space Instrument Section, where my people built all of the instruments for the Ranger, Mariner, and Surveyor programs. And I was involved in the Worldwide Tracking Network. But I tell you that to let you know I've got a bit of a technical scientific background. And as part of the work in the IGY and the satellite, I learned a great deal about this universe in which we live and spacecraft Earth on which we're riding. And I had a great deal of admiration for the universe, because as I looked at the universe, it seemed to me it was really put together according to a design. And when I use the word design, that demands a designer someplace. And so I really had no doubt, I was in my early 20s then, that somewhere there was a designer, call him God if you will, that put it all together. Just didn't dawn on me that this person I call God could be interested in me as a person. And I'll say that because I was a busy churchman throughout my early life. In fact, I was chairman of the board of one of the big name brand churches in Pasadena 3 years in a row, but didn't really know what Christianity was all about. I certainly didn't open a Bible, because that's a bunch of ancient writings that couldn't possibly apply to 20th century life. But then God caught up with me, and I finally had to open my eyes to the world around me and the universe and realize it was put together according to a design, and that design probably would include me if I just found out how to find out about it. I did become a Christian. I had another career after JPL. I went to work at a high-tech research company in Pasadena called Electro-Optical Systems, and we were involved in just all kinds of military, scientific, engineering work. And I left JPL because I was very frustrated. It was important to me to prove I was a success, because I thought I was probably one of the most important things in the universe. And so I had to prove I was a success. And in the government environment, you don't do that. In fact, I found out success was no way to get ahead, which is a sad commentary on working for the government. But we'd launch another successful satellite, and our money would stop, and we'd have to write another proposal to the government to get some more money. And so success was not the way to get there, and that just didn't satisfy my need to prove that I was somebody. I went to work at EOS. I found out they had just one customer when I went there, the US government. So they did research and development for the government on what's called the CPFF mode. Cost plus fixed fee means the government paid all of our research costs and gave us a fixed fee profit on top of it. But again, success was no way to get ahead. And so I left in frustration again. I went to UCLA on staff for a while. My family came apart. I ended up alone with 5 kids. Didn't know how to raise myself, and here I'm trying to raise 5 kids. And in my frustration, I turned to a lady that had been my secretary at Electro-Optical Systems. In fact, she's sitting here in the audience, Beverly. And she had a strange kind of peace in her life that I didn't understand, but I was interested in. Turns out she was one of these delightful creatures that calls himself a Christian. I'd hear the word Christian and the hair would sort of come up on the back of my neck, because I knew I was in with a bunch of religious fanatics that I wanted nothing to do with. I was busy in the church, but somehow that was strange to me. Well, my textbooks at Caltech told me a great deal about this marvelous universe, but they didn't tell me how to live life. But I found out through Beverly and in my church experience, there was a book in the church called the Holy Bible. And some people call it the Manufacturer's Manual. when all else goes wrong, get out the instructions and read it. And so I finally started thinking deeply about life, and I came to the point in my life one day when I was driving in my car on the 210 freeway through Monrovia, and I just suddenly felt the overwhelming presence of Jesus Christ in that car with me. And I said, Lord, if you want me, I want you. My life was transformed dramatically in that day. Beverly and I had a date that night that I took with some reluctance. She wanted me to go down to Anaheim Stadium to hear a preacher named Dr. Billy Graham. And I agreed to go. And I didn't tell her what happened to me in the car, but I went down with such joy and peace in my heart that I could hardly believe it. And when he gave the invitation to make a public declaration of faith, I was on my feet and down to the infield to take my stand down there. So as a result, I started looking at the universe quite a bit differently. If you study the universe and you study the earth, you'll find that almost everything that exists is the way it is to allow human life to exist on this earth. To me, the earth is made for man, not the other way around. The human body doesn't use what minerals and things that are available because they're there. They're there because our bodies need them. And so when I began to realize that, I took a different look at the universe and decided I needed to learn more about it. And so I'm in the process of writing another book with my friend Dave. It'll be called Spacecraft Earth, a guide for visitors.
Passengers.
Yes,
Passengers.
a guide for passengers, and hopefully it'll be out toward the end of the year. We don't know. Creation Ministry is doing the publishing. But as I began to study the universe, one of the questions is, where did it all come from? And I know that there's a major school of thought that everything started with a big bang billions of years ago, that the whole universe was packed into something smaller than an atom and suddenly exploded and made everything. Now, estimates are, do you know how many stars there are? There's 10 to the 22nd stars. That's 10 with 22 zeros after it. That's more stars than there are grains of sand on the earth. And so that's a lot of stars. And so as you look at this many stars, certainly some of them are going to have planets. And there's a great deal of interest now in trying to find out if life exists beyond our planet or beyond the solar system. And so as I began to think about all of the features that the earth has that allows life, and without any of these features, life would not exist. And so I've tried to put together a little story about that. Let me start with an astronomical example. The Earth is roughly 92 million miles from the sun. That distance is very crucial for a sun like we have and for that distance, because that determines the temperature balance of the Earth. The temperature of the Earth is very important. You hear all of the global warming cries of alarm. Just a few degrees temperature difference will make life difficult. If the Earth were 5 or 10% further away from the sun than it is, the Earth would become so cold all of the water would freeze. And ice would sink to the bottom of lakes and rivers and the reservoirs. We would not have liquid water on the Earth except maybe a couple centimeters on top on a hot day. On the other hand, if the Earth were 5 to 10% closer to the sun, it would be so hot the water would boil away. So that distance is a very crucial distance to allow Earth to have life. Another example, we have a moon 250,000 miles away from the Earth. That's a very crucial distance for a moon the size that we have, because as the moon rotates around the Earth, it causes tides in the ocean. And those tides move the water and oxygenate the ocean so that life can exist there. If the moon were 10% closer, the tides would be so strong, they would probably erode the landmass down. If the moon were 10% further away, there would not be enough tidal action to oxygenate the ocean. So you can look at that 250,000 miles and say, that just happened. But I don't believe it. That's put together for a very crucial purpose to allow life to exist on this earth. That's an astronomical example. Let me go to an atomic example. As probably most of you know, 98% of all the substances on this earth, when they change from a liquid state to the solid state, that is, when they freeze, become more dense. And we have one substance that's notably different. It's a substance we call water. Because when water freezes, ice expands and it floats. If that were not the case, again, ice would sink to the bottom of lakes and rivers and the reservoirs, and we would not have liquid water on this earth if water were not different than everything else. An accident of nature? I don't believe it. So you can go through many, many features of the earth and its environment, and you can start adding up the probabilities. Are there other civilizations? Well, what's necessary? First of all, if you have a planet, it's got to be located within the galaxy habitable zone. That is, the right distance from its star to have the proper temperature and the like. It needs a stable star with constant energy output like our sun. Our sun is remarkable among stars in being so stable. Many stars flare up and come down and flare up and come down and just have no stability at all. And the planet must be formed within the habitable zone around the star. For us, that's this 92 million miles. The planet must be in a stable orbit, keeping a steady distance from the star. And these little percentages, I'm saying, if you find a planet someplace and you want to apply the criteria to it, what's the chance it'll be within the galaxy habitable zone? I'll say 10% maybe. Does it have a stable star? Well, maybe 10% of the time it would. Would it be formed in the habitable zone around the star? Maybe 10% of the time it would. It needs to have a steady distance from the star so it's not coming closer and further, getting hotter and then colder and hotter and colder. One thing that helps the Earth is protected by the gas giant planets, which intercept space debris that's heading in toward the Earth. The rotation speed of about 24 hours is important because that's the day and night sequence that we have. If the planet had a 2-hour rotation, it went from light to dark every 2 hours, then any kind of stable life would have quite a difficulty existing. The planet needs to have a suitable atmosphere. It needs to be oxygen rich, at least to form life as we understand it. The atmosphere must have enough depth and circulation. 10% chance again. A planet with the appropriate mass having the right gravity so that we stick to the planet but we're not crushed by it. Again, maybe 10% of the planets might have that. The planet needs abundant water to have life existing in that, to support upper forms of life. It needs to have a reasonable ratio of water to land mass. Again, maybe 10% of them might have that. In order for the planet to operate properly, it needs a crust capable of plate tectonics so that it can have some dynamic activity. Very important, it needs to have a magnetic field with the proper strength because the magnetic field protects us from radiation particles coming in from outer space. And that's what caused the Van Allen belts that we found out about. But if the cosmic rays and solar wind is stopped before it gets down through the atmosphere, then it allows life to exist. These kind of rays and particles are very destructive to tissue. And so places like Mars, they're very concerned about astronauts that might be on the surface of Mars and not protected from all of the solar corpuscular streams and cosmic rays. So again, maybe 10% of them might have that. I mentioned the moon of proper size because it needs to make certain things happen on the planet. A planet needs to have an available source of abundant carbon compounds because life as we know it is carbon-based. That's why it's called organic. It needs to have trace elements of the right type and quantity because we have a number of different kind of metals and minerals that allow our cells to behave properly. And I could go on and expand this list further, but if you take all of these 10% and you multiply them all together, it turns out to be 10 to the minus 15th. I estimate that there may be 10 to the 12th planets out of the 10 to 22 stars that could have these characteristics near a G2 sequence star, etc. And it leaves less than one planet that would qualify for all of these criteria. So in terms of searching for other worlds and other civilizations, my advice is forget it, because statistically and logically it is just so out of bounds. Another, what I will call fable, where did the universe come from? There's a school of thought that says everything started with a big bang billions of years ago. And that says that all 10 to the 22nd planets and all of space was contained in a little glob, they say smaller than an atom. Now, I don't know what kind of thinking could imagine that all of that is in something smaller than an atom that suddenly blows up. But that's what the Big Bang Theory says. And to me, it's just inconceivable that people could believe that. So that's some conversation about where the universe and the earth came from. Where did life come from? It's hypothesized that life started with a single cell someplace that suddenly got jump-started into life. And where would a single cell come from? Well, there's many organic compounds floating around in water and the like. Most of them that we find now come from living forms because they're called organic chemicals. But we know even in meteorites there are some organic compounds, and people have said, well, maybe all of these just came together and stuck together and made a cell one day. And what does a cell consist of? Well, it's got a membrane on the outside, it's got a nucleus, it's got some chemicals inside the nucleus called DNA that instruct the cell how to operate, because the cell is really a real chemical factory. All kinds of things are going on. It has to take in nourishment, it has to get rid of waste products. So how do you define life? Well, it's something that can take in energy, grow, and reproduce. And so where could a cell have come from? Chemists have analyzed cell walls, and this chemical formula shows you a very small fraction of a cell. And in between, each time you see two lines joined, that's where a carbon atom is. So this is really filled with carbon atoms. And to make a cell wall, this would have to be repeated hundreds of thousands of times over to put together a membrane that would contain a cell. And to expect all of these to suddenly accumulate and latch together is really straining the imagination. And not only you have to have a cell wall, but the cell wall has to be selective in what it takes in for food. So they found the cell walls have a number of little orifices that are very specific to a given molecule. They'll take in a given protein food and ignore everything else. Other ones will get rid of waste products. And so, again, not only all of the cell wall has to stick together all of a sudden, accidentally, from molecules just banging on each other, but they've got to have many special features like this. And then even if you could put together a cell with the cell wall, nucleus, DNA, protoplasm, what jumpstarts it to life? Somehow that cell has to get suddenly energized to live and reproduce. And we know probably the best approximation of a cell is a dead cell. And when we have a dead cell, there's no way to jumpstart that to start living again. So the cellular structure is very interesting. Starting with just one cell animals, some of them are very complex because there's some of them that have little filaments sticking out of the side that'll propel the cell through the fluid that it's in, called cilia. And this is a left side, an electron microscope picture of a cilia, which is hooked to an outboard motor in the cell wall, and so it spins. And so this cilia fiber that sticks out spins in such a way to propel the cell. Now, not only if you're going to make a cell by accident, and you get all of the right chemicals together to make a wall, some of them have to join together to make this crazy little outboard motor cilia. So again, I don't see any way that this could happen by accident. I really don't. And you could go through the sequence. If you start with a one-cell animal, then somehow it morphs into a two-cell animal. I say animal because at some point the cells diverge between plant and animal, and what would cause that to happen? And you can go beyond a two-cell structure and go to multi-cells, and pretty soon you end up with some very complex structures, all of which happened by accident. The environment, the evolutionists say. So let me jump from the tiny cells to probably the structure that's of most important to us, and that's the human body, which is just a marvelous assembly of mechanisms, chemicals, reactions, and other things. And I like what my friend Kenny Poore used to say when he'd get to this point of examining the universe. He'd walk over to a piano, and he'd lay his hand on the piano and say, now, the universe and the body is too complicated for me. Let me talk about a piano. He says, when you see this piano, there's two possibilities. Either there's a designer and a piano maker, or it just happened. Did that piano just suddenly appear because nobody did anything? Did they appear in stores? So there had to be a designer and a piano maker. And I'll say the same thing for the human body, because the more you study the human body, the more amazing and complex it becomes. In Dave's and my book, we go through a number of features of the human body, starting with, say, saliva. Saliva is a pretty important fluid. It's produced by saliva glands. There's 3 different kinds of chemicals in the saliva, which is necessary to keep the mouth moist, to pre-digest food, and to have some healing powers, and also bactericidal powers. So how did saliva happen? Did some evolutionary quirk suddenly produce saliva glands? And what did a mouth do without saliva glands? And there's so many features of the body that you can go through asking questions like that. Where did they come from? How did they exist? And what happened before? And I think, to me, one of the most amazing features of the human body is vision. If you look at what causes vision, vision did not happen one piece at a time. An eyeball didn't develop. And if you look at all of the different features required to produce vision, there's just so many. If you look at, this is a picture of an elbow showing how the bones fit together, and it's a good thing the socket's round and the the joint's round because it'll move. If that was square, because evolution happened to produce a square one, it's not going to move. And it gives different degrees of rotation and freedom, and it's just a marvelous piece of mechanism. And then along with that, the bones don't do any good without muscles. They don't do any good without blood vessels. They need nerves. And so in terms of developing by evolutionary means, an elbow just couldn't develop without a piece at a time. A foot has many similar rotating joints in it. I think it's like 30 different rotational joints in a foot, very complex structure. Now, some people believe that we somehow came out of being monkeys at one time. And if you want to take a look at the comparison, here's a monkey's foot versus a human foot. The monkey's foot is built for climbing trees, the human foot for walking. Totally different joint features, totally different skin, totally different activities. It's not a redesign. The human foot is a totally new design from what the monkey has. And so if you try and rationalize how the human body could have come about through undirected random changes, as the evolutionists believe, it just doesn't fit. It's not a redesign, it's a totally new design. I talked about eyesight. There's a number of critical things that give us sight. We have an eyeball. The eyeball has a lens in it. The lens has an iris that regulates the amount of light. At the back part of the eyeball is a device consisting of rods and cones that translates the light photons falling on it into electrical impulses, which then go through a nerve to a certain place in the brain. And the place in the brain is able to recognize and form images. The eyeball has 4 muscles that move it. It has an eyelid that protects it and keeps it moist. It has a fluid in it that has just the right index of refraction to image light that's come through the lens onto the focal plane at the back of the eye. The lens is able to move, controlled by the brain, to focus the eye at different distances. There's no way that a feature such as vision could come about through independent activities. You can't have an eyeball form and later on a nerve. And not only that, we have 2 identical eyeballs, have holes in the skull to fit them, and so it gives us stereoscopic vision. So again, in our book, I lay out a whole bunch of characteristics that are not reducible. They all have to be present at the same time, or you don't have vision. It just can't have come about by accident without some kind of direction. So again, like when I looked at the universe and I said, I see design, this is fully designed and requires a designer and somebody that put it all together. We have another feature called the brain, which is the most phenomenal computer that you can imagine. And the brain has many nuclei in it, and the brain has nerves that go down to muscles and sensors in the skin, and each one of those nerves is a single cell that starts in the brain, goes down through the spinal column, branches out, and goes down into legs, feet to give us feeling and to command our muscles. And so how do these, in a growing embryo, how do these nerve cells know which path to take to get from the brain down to the big toe? Again, it takes some kind of intelligence to design it and make it happen. And the nerves carry electric impulses. That's how they transmit their information. And when a nerve ends, it translates that electric impulse to a chemical impulse across a barrier to another nerve or another cell. And again, all this happens at lightning speed time. And I don't see any reason to ever say that I don't know how many nerves we have coming down the spinal column, tens of thousands, how they could have happened by accident and just crept down the spine and poked out at the right spot. And the body has so many interesting features that we can spend a week talking about them. But I'm not here to convince you that the body is unique, but it is marvelous. The last part of my story has to do with time. And after I became a Christian, and I was very much in the camp of the geologists that believed the universe was 11 billion years old and the Earth billions of years. In fact, when one year I went back to Northwestern University between the Navy time and Caltech time and took some courses. And one was geology. And so we took field trips around Chicago and picked up fossils that were called trilobites. Get rid of the breath sounds. Yes. And so I fully believe these are all millions of years old, and I had no reason to doubt it. But then I got interested in a group called the ICR, the Institute for Creation Research, and they published a monograph by Dr. Barnes that talked about the magnetic field of the Earth. And based on conjectures of measurements of the magnetic field of the Earth, Dr. Barnes made estimates as to how old he thought the Earth really was. And this really caught my attention because I've always been interested in magnetic fields. They were part of our Explorer 1 satellite project. The magnetic fields affected the cosmic rays that we measured. Magnetic field measurements have been made very accurately for the last 100 plus years, probably 150, ever since Gauss built his first magnetometer. And as they've looked at these measurements over the last 100, 150 years, they've found that the Earth's field has decreased 5% worldwide in the last 100 years. Now, to a geophysicist, that's a startling thing to realize, because that's a huge energy change, first of all. And so now you can say, well, if the magnetic field has been decreasing for 5% for the last 100 years, if you go back 200 years, it's going to be 5% and 5%, like compound interest in a savings account. And if you go back in time a few thousand years, these 5% every 100 years add up pretty fast. And so if you go back a few thousand years, the Earth's field, which is the measurement's about a quarter of a Gauss right now, would be a mini Gauss. You go back 10,000 years, it would be 100 or 1,000 Gauss. And if you go back 50,000 years, it would be so strong that the Earth would come apart. So I guess the question is, what causes the Earth's magnetic field? And this is what Dr. Barnes put in his monograph. There's really only three possible explanations of where the Earth's magnetic field comes from. One is that there's a big permanent magnet in the center of the Earth. Well, we know in the laboratory that permanent magnets do not exist at elevated temperatures. We know the center of the Earth is many thousands of degrees hot. So there is no known magnetic material that would maintain magnetism in that kind of temperature. So you can rule out a big permanent magnet in the center of the Earth pretty fast. The other is that maybe there's some kind of dynamo in the center of the Earth that's running and creating electric currents that flow through the Earth and make magnetic waves. But what would run the dynamo? There's no motor down there. You can't have perpetual motion, so they can pretty soon rule out that there's some big generator down in the center. The third explanation he comes up with is that somehow when the Earth was formed, it had residual electric currents in the Earth, and they're slowly dying out because of resistance. He's done some calculations. There's two physical parameters that determine current. One is resistance that slows current down. The other is called inductance that tends to keep current flowing. And so he's estimated the resistance and conductance of the materials of the Earth, and lo and behold, it comes out about 5% every 100 years that you'd expect. So his conclusion is somehow currents were formed in the Earth when it was first made, and they've slowly evaporated. So if that's true, and you go back 10, 20,000 years, that's about as far back as you can go before the Earth becomes physically unstable. And so that put me in the young Earth class. And so I'm convinced the Earth is 10,000, 12,000, 15 at the most, 1,000 years old. And so if that's true, then forget the Big Bang, because that's not where we came from. The Earth was created by God for a special purpose, and I can't speak for the rest of the universe, but at least I can try and hang a time scale onto planet Earth on which we're riding. So to me, that made a big change in my thinking about the cosmos, the universe, and even mankind. There are several consequences of a strong magnetic field several thousand years ago. One is there's a method of dating dead organic material called the carbon-14 dating method, and that involves measuring the amount of radioactive carbon-14 in a sample of wood or pottery or whatever might be found. When that article was formed, or if it was a plant when it died, it would then stop exchanging carbon dioxide with the atmosphere and lock in the ratio of radioactive carbon-14 to normal carbon-12. And at that point, the radioactive carbon-14 starts decaying, and by measuring the amount of 12 versus 14 and knowing the half-life of carbon-14, you can estimate how long ago that plant died. Well, if the magnetic field was really very strong several thousand years ago, there would not be as many cosmic rays and particles hitting the atmosphere, creating carbon-14. There wouldn't be much carbon-14, and so if you got a sample from that time period without knowing the atmosphere, you say, oh my, there's not much carbon-14 in this, it must be very old. And so that's a fallacy that science has. You can't measure things from the past or the future. All you can do is measure what you have in hand right now. And so without knowing what the atmosphere was several thousand years ago, you can't tell. Another conjecture I came to is you read about the extended ages of the patriarchs in the Bible, of several hundred years, 900 years. We know that cosmic rays and radiation degrades cells. And so the more cosmic rays we get, the shorter we live. If there was a very strong magnetic field 5,000 years ago, there wouldn't be many cosmic rays, bodies would not deteriorate so fast, and that might be an explanation for the long lives. So, to me as a scientist, that magnetic field decay really opened my eyes as to taking a very fresh look at the cosmos and the Earth and trying to put it all together. And so I'm just very glad that I suddenly realized that God is real, that He created us, He has a plan for our lives, and it's my job to find out what that is. So thank you very much for inviting me.
Would you like to take a short break and then
Sure.
answer some questions? Okay. Let's take about 5 minutes. Come back.
Okay, ladies and gentlemen, welcome back. We're going to have a short Q&A session here. I wanted to be sure to point out Beverly Richter, who's sitting here, his lovely wife, who's led him to the Lord back 45 years ago or so. Is that right? And an old-time friend of Henry's is also here, Gary Gray, who's been the head of the Orange County Communications back from the 70s is when he knew Henry, and so it's good to have an old friend here of his. I wanted to also point out that World Magazine just came out today with a 4-page story on Dr. Richter here called Rocketman by Sophia Lee. So if you get World Magazine, you'll enjoy seeing this. You can also find it online, so just go to worldmag.com and search on Rocketman. You'll probably see this article, and there's some interesting pictures of the Explorer 1 days and pictures of him back when he was working at JPL. So I hope you're enjoying this talk. It's really an honor to have an American Rocketman VIP here with us tonight. So we'd like to invite Henry to come back up and take a few questions.
Okay, who's first? Yes.
Yeah, I just want to say I'm really impressed by what you were talking about, the cosmic rays affecting the lifespan, because I've been studying gerontology pretty intensely. I've never heard of that. It's quite fascinating. I just really want to know Dr. Barnes' research with the magnetic fields. That he was able to prove that it was a steady state decline or that it was exponential?
It was steady state, and they have measurements every day for 150 years,
Wow,
so
that's fascinating.
you can draw the curve right through them. Yes.
Hi, can you address the magnetic field reversal, like the samples from the Earth's the ocean seafloor, it shows like it reverses?
Yeah, I cannot explain reversals. I'm not sure what would cause them. They're inferred because they've measured the magnetic properties of rocks as they're formed. And I've got personal doubts about the accuracy of those measurements. So,
What would happen if the Earth's magnetic field was too strong? Most biological organs don't feel magnetic fields too strong. Any idea what would happen to the ground and the soil and the water with strong magnetic field?
well, it wouldn't affect the water so much. The Earth's magnetic field mainly affects particles coming in, but if you get a magnetic field of several thousand Gauss, then it's going to start putting forces on rocks and magnetic materials, and they'll start coming apart. Yes.
Would any secularists use reversals hypothesis to account for the gouts that you've been mentioning? In other words, it could increase to a certain amount and then reverse and then diminish the gout, and thereby over a long period of time never achieve the state of adversity that you described?
So I can't really answer that. I'm just not sure. All I have to go on is what's in Dr. Barnes' book, and measurements that we've made now, but many questions in history of, yes.
I came in late, so this may have been covered before I came in. Do you believe God created the earth in 6 24-hour days
Sure.
and rested on the seventh? Do you believe?
I can't imagine needing to take longer, because God can breathe whatever he wants to create. And
Do you believe the earth is approximately 6,000 years old?
say that again?
Do you believe the earth is approximately 6,000 years old?
6, 12, 15 at the most. So it had to be created the way it is. Like when an author writes a book, he doesn't start putting the character in a house, building the house a stick at a time. He writes the book with everything in place. And to me, that's what happened to the earth.
Do you believe that there are other worlds? Do you think God created other worlds like ours, stars with earths in this zone of, that we're in?
He could have, but
And you think maybe being in heaven would be the discovery of those in this?
well, I don't read anything in the Bible about other worlds, so God can do whatever he wants, but I don't read. Don't know.
It's amazing he made the world so large when we're so small. I wonder if there's a reason for that largeness.
Yes, although the world's pretty small compared to
I mean, the universe.
the sun or the outer planets even. And, you know, one aside I'll make about the young Earth, when you look at the history of billions of years, and you see that Jesus came recently, that's way down in history, unless the Earth is only 12,000 years old, in which case Jesus' arrival was very much on the scene after the Earth was made. It wasn't billions of years later. Yes.
Do you think that secular astronomers have any rational explanation for the singularity that you spoke of earlier that produced the Big Bang? In other words, where did that come from?
It came from imagination.
So you don't think they have a viable explanation for that?
No. Yes.
I've been amazed at how migratory birds have a magnetite in their head or their ear to navigate, and how it gets there, whether it's created or evolved as a bird's growing. How does the body sense little particles of iron atoms and send them to the ear and make it build a little crystal so the bird can navigate when it's
You navigate thousands of miles and come back to the same place.
yeah, and how
That's the way they were created.
and how does the magnetite in each new bird get to there? How does it know to get to? That's amazing to me. However, it gets to the ear where it's supposed to be. How does the body separate magnetic from non-magnetic iron in the food, send it to the ear?
Well, that's just the way it was built into the nerves. Yes.
I'm fascinated by magnetic fields, but I don't know much about them. Have you come across any research indicating the effects of the increase or decrease in the magnetic field as impacting biology, life, in terms of the blood chemistry and the minerals that are stored in the body affecting life development and life?
Not really, because the magnetic field is not strong enough to exert any force or action on these. It's just like the birds. They can sense some kind of maybe pressure from them, very tiny pressures. But
You're probably aware of these companies that have sold the magnetic pads and straps that supposedly by rearranging
yes,
the iron in your blood.
or they put them on gas lines in the car. Or,
But now they even say there are certain places, if the magnetic field is strong in your backyard, you should lie on the ground to get the metabolism,
soak it up.
the redistribution of iron in your blood.
No, that's snake oil. Yes.
Yeah, when you were working on the satellite, do you have to deal with the Van Allen belts? Do you have any information on that? Because I heard that that's a part of the field that reaches into space that protects the Earth from cosmic rays.
Right. If you've seen pictures of a magnet with the field lines coming out of the magnet, that's the way the Earth is. There are magnetic field lines that come out of the poles, and certain strengths of those magnetic field lines will trap particles, and they spiral down the field line. And so there's just certain regions that will trap particles. There's 3 known Van Allen belts at this point. And so you don't want to fly through those in a spacecraft. They can cause damage.
Well, there's like a lot of people in Britain and some other places that are very skeptical about people having passed those belts. What are your thoughts on that?
You can go through them pretty fast, that's all right, but
But won't they, because I've heard that a living creature would get destroyed by those Van.
well, if you're exposed, but the spacecraft captures most of it.
Like a lead shield.
Yeah. There's a lot of them, but they're not terribly energetic.
Didn't Explorer actually discover the Van Allen belt?
The Explorer 1 discovered it. We didn't realize it at the time. We thought something had gone wrong with the satellite. There were certain times that we got no data back at all from the Geiger counters, and I racked my head, what did we not test? And it was not until we put Explorer 3 up that had a tape recorder in it and recorded the full orbit, because Explorer 1, we could only get data when it was over a ground station, and we only had like 11 ground stations. And we finally realized that it was certain parts of the orbit that the data stopped, the Geiger counter was saturated, and then when we got the tape recorder, we could see the count go way up, go into saturation, come out of the other side of the belt and start counting again. And I was sent to Russia in August of 1958 as part of the IGY meeting to report on the Explorer satellite. And at that point, we had complete data, and we were able to explain it. But up until that point, it was a real worry that something had gone wrong. Yes?
Hey, I've been curious about the evolutionary geologists taught to point some hills and cliffs and fossils and say they're millions or billions of years old, but you see how fast things are eroding. Everything would have been ground to powder. The fossils would have been destroyed, the soil turned over, volcanics and floods and comet hits. Everything would be evenly emulsified, and the layers, like in the Grand Canyon, have been all churned up and just obliterated. So the rates of erosion, I can't imagine that they're that old as the official theory proclaimed.
There are many books written as to why the Grand Canyon was made in a short period of time by a lot of water rushing through it. And they cite the Mount St. Helens volcanic explosion where they had this huge lake formed, and then suddenly the water broke through, and they find the same kind of strata in the canyon that water cut that resembles the Grand Canyon. Yes?
What did you find as your most formidable task in putting up Explorer?
My biggest worry was temperature control. We'd never put an object out in space for any length of time. Satellite spends 45 minutes in bright sunlight and 45 minutes in deep shade looking at minus 300 degrees. And so the skin goes from very hot to very cold to very hot. And so we put a lot of effort into trying to determine what kind of coating, what kind of skin. We insulated the electronics in the center to smooth out all of these wild swings. And we hit it within 10 degrees of where we wanted it to be. So we sent, if you look at the Explorer, there's a picture of the Explorer on the front of my book there. I just had a book published last year. Yes, you see the stripes on the satellite. Those are ceramic stripes, and we gauged the width of those to determine the temperature, and they worked fine. Incidentally, I got a very nice notice a couple of months ago. This book, which was published last year, has been nominated for the Book of the Year, the Emmy Award of the American Astronautics Society for 2015. So, got my fingers crossed on that one. Yes.
Do you recall the Echo satellite, one of the first satellite or balloons we put up I think in the 50s?
Yes.
And the paper used to publish the time it would fly over your city, and you could see it. One night when I was young, I went out and watched it, and it went over right on time. Then about a minute later, there was something following exactly the same distance and spot overhead in the sky. And I wondered if there was another part or a capsule separated or something. And there was something was following it behind exactly like a minute later, the same track in the sky.
Yeah, I think the nose cone was behind it.
I always wondered what that was. But just always curious.
You know, several people this evening have told me they saw Echo even in the daytime.
I saw it in the daytime. Walking down the street, and a man says, "Look, that's the Echo satellite." By golly, it was just moving across broad daylight.
Okay. Yes.
Do you think a worldwide flood had any effect on the magnetic system, Earth's magnetic field?
It certainly must have, because the flood would saturate the Earth and change its resistivity. But we don't have any magnetic measurements back then, so
Maybe it shorted it out, and that's why it's losing 5% every.
maybe. Okay, Jim.
Thank you. Well, folks, that's all she wrote. Come back in 2 weeks, okay?
Thank you.
I think Dr. Richter has some copies of his book, if you're interested in getting it. That's a really great read, I think.
It's mostly kind of self-taught stuff.
Right here?
Questions?